So one is checked exception, checked. One is checked and another is unchecked. Okay. So checked means compile time exception. When compiler, when you going to compile your code, it checks whole code, and if the logics are all means not logics are checked in runtime, but if the syntax is correct, then syntax is not correct, then it will show check and the checked exception. Okay. Unchecked is which is not caught, cannot caught in compile time by the compiler. That is during the execution it will throw the exception, like the array index out of bound.
Okay.
So remember this thing. So which ID you prefer? You use like
I use IntelliJ by itself. Yep.
I use both, like Eclipse also good.
It's suppose, yeah, I'm not used that in a while, so.
So see, so I was printing the whole array.
Okay. So I get one question for line number 5. Like you are saying, array I equals I, right? So why are we initializing like I as an array I?
Array out one. Yes, no. I am just writing a logic, nothing is big. So I am nothing. Just I was printing everything. So you can print I as well. I was just copying the each I into array of I and just printing the array. There is nothing inside in the logic. Random thing I was doing here, just showing you how array works. So this can be a character array, this can be a string array, this can be a float of array, like let's say this can be a character of this. This can be a float of array. And when you define something as a float, it only stores float. It is a characteristics of array. Array can only store similar kinds of elements. So if it is an integer, you cannot store a character there. Okay. So array is first contiguous location, means it has index of 0 to 1, 2, 3, 4. So it is contiguous. Okay, there is no break. 0 start from 0 and it will incremented by 1. So it is contiguous and it stores always the same kinds of elements. When you declare a integer, that is integer type of array only. So there is one thing is also there in Java. There is int is there and there is integer is there. Do you know the difference?
Integer means inner class.
Inner class? No. Inner class is nested class. No. Integer is a wrapper class.
Oh, wrapper class. My bad. I'm sorry. It's been a while.
Inner class is different. Inner class is like static. It is called nested class. Static class inner. It is a inner class.
Okay.
Class inside the class. But wrapper class is every data type in Java has a wrapper class. Means it's for every, like int has integer, char has character, string has string class. No, not string class. String itself a class. Float has float wrapper class. So there is something boxing and auto boxing is there also. But we will go through the topics later. But as we are checking the arrays today, doing the arrays, we'll concentrate on that. So
like converting a primitive type into, object type, and
yes.
and the another is like the vice versa, right?
Vice versa, yes.
Gotcha.
So there is different methods are there, value of methods. So we'll check that. So here the see, this is a final class. Integer is there. So it is a structure of a integer class. It extends number class, implements comparable. What is comparable, you know?
I forget it, man. Like, I might have to check it again.
Yes. So comparable has only one method compared to. So that
Okay.
means it's a functional interface. We'll check that. It is an interface. Just remember.
Okay.
And this is final. Many things are there in Java. So this is what like basic. How can you? How do you means if someone tell you like create an array of array? So this is a way to create an array. Another way you can do like if you have elements, you can just put the elements there. This way. This is also you can this way you can also create the array. Okay.
And like, if we are solving lead code, right? So what is the best thing to do? Should we go with line number 6 or should we go with line number 7?
6, always 6.
Okay, gotcha.
Because it is like hard coded, right? The elements you are putting here, it is hard coded. No, sometimes you have to do 7 also. It depends on the situation. I will show you.
Okay, gotcha.
Depend upon the question, the solution. Okay. So next thing, anything remaining for solving something. Okay. Now just let's say you have a 3 digits in your means 3 elements in your array, 10, 23, and 45. So I want you to search if some elements is present in the array or not. Okay, I am telling you like search. Tell me it is 55 is there or not. What you will do in this array?
Can we like it's not going to be the optimal solution, but like, can we
No,
use
brute force.
if else, like let's say like let's say like run a loop first and put if else inside, and if array at I equals 55, so it's gonna be return yes. If array at I is not, so it's gonna go again and search the array.
Yes. Can you write the program or I think you can control my screen. Right? No.
Let me try. Okay. I can control. Just give me a minute.
Okay. Remote control. Are you sharing or are you?
I'm not sharing.
Okay. So let's see. I am doing so. First, let's see. I'm first checking the length of the array.
Yep, correct.
Taking the length. So first searching is by linear. That is first thing we can do. So length is a function in array. Okay.
I got one question. So why are you saying like the length searching is linear in that line number 7?
Length searching is linear. No. Searching is two types. I am saying. One is linear. Another is binary search. So that for the brute force approach, go for linear search, and for optimization, you can go for with binary.
Okay.
So what I am doing here, I am just run a loop, and as you told, it is correct. I will go each and every elements and check it is
array at I
equal.
equals uh,
Just do practice with me.
okay, so let's do. So do you want me to open? Okay.
Mm-hmm.
That will be helpful.
So 85 means it's found.
Yep.
It does not print anything because I have not.
Because we didn't put return.
No, I am not returning anything. Not found. We can do one thing. We can do a flag here or boolean. Boolean flag as true. False. True. Then we can say that this is not found. It's okay. So tell me, you understand the logic or not? What are you thinking?
If flag equals true.
Why I
No.
am did this line? For printing purpose. So if I do else inside, it will like every time it will print not found, not found. You understand?
Okay.
If you
Okay, got you.
no,
Because like till the time it didn't found like 55. Let's say like 55 is on third position, and it's gonna print 2 times else, right? If
yes,
you
yes, as it is not found, so it will
okay.
print not found and not found. Yes.
Okay.
So that is the reason what I did here. There may be any other logic as well. For me, I thought that if I can change the flag from true to false, that means it found. And if it is not changed, first it was true and still it is true, then we can tell that this is not found because the flag has not changed inside the if block. So it will not go inside if block. So what is the time complexity here?
It's gonna be big O of I mean n,
Yes.
because it's just running the loop once, right?
In what is the what the meaning of in here? Length?
Meaning n means like it. It means like the loop has just run once, right?
No.
Oh,
In is the array size here.
okay, okay, gotcha.
Array length means so the loop will run till the length of the array in most case, right? In this case, 55 is not there, so it will run 3 times the loop for checking. So here the big O of n means here the n is size of the array in ORS case. So big O means ORS case. Big O time comes big O we do for ORS case. So that means this is ORS case and n is the size of the array. So n depends upon the problem question. So what does it mean? So here n means the size of the array.
Okay. I got another question too for you. So why did we do a break in line 16?
Okay. See, the problem, let's say, the problem, the elements 17, 19, and I am trying to search 45. I am trying to search. Okay, so it is present, right? Hello. 45. I am the target is 45, and it is present, right?
Oh, I get the idea then. So that means like if we do break on number 16, like once it found 45, it's not gonna go again,
The loop.
right?
Yes.
Oh,
So loop will break. So that saves our time, right? So
yeah.
why the loop will again check the remaining elements, because we already found that.
Okay.
That is the logic. You cannot do the loop break, but that helps for time complexity. Okay. So this is brute force linear search. We can do a binary search, but for binary search, first array should be sorted. That is the first logic.
So binary search, what do we have to do?
Array should be sorted.
Uh, Array should be
Sorted. Sort.
oh, sorted. Okay, got you.
That means in ascending or descending order, it should always be sorted. If it is not, you can do that. Let's say 99 here, 3 is there, 45 here. So you can do a arrays is a class which has a method sort. Okay, that means now the array is sorted. Arrays. So you can do any other sorting logic as well, but Java has the sort method, so we use this in LeetCode as well. Arrays dot sort. So arrays is a class. This is a class in Util. That is not the array. It is arrays. Okay. Arrays has many methods. So one method is sort, which is very famous. We use that.
Yeah. I get another question for you, Saurabh. Like, so there are just two ways to solve the problem, right? So one is brute force and another one is optimal.
Yes, this is linear search and another is binary search. Yes, tell me.
Yeah, I mean the search for search, that's fine. But if we want to solve a problem, there are two ways, either brute force or optimal, right?
Searching is
Okay.
two ways you can.
Okay.
Normal search. This is the array search.
Okay.
It depends upon the problem, right? If you are doing a hash map problem, so they are searching is different. You are going to each key and search every element. So that depends upon the problem. Say here, what we are doing here is array search, normal array searching. So here you can do a linear search or binary search. Binary search, the array should be sorted. Why array should be sorted? I am giving you the logic, so you will write the code for this. So this is an array. I'll do a LeetCode problem. Okay, LeetCode we have binary search is there. Yes. So this is an array. Okay, let's say different elements is there. 12. Okay, I am writing in ascending order. Okay, 25, 77, 99, and 111. Okay. So let's say I am searching the element of 17. So linear search, we will go every element and check, right? That is the linear search, right? The brute force approach.
Yep.
So now your voice is breaking.
Can you hear me?
Yes, now it's okay.
Okay.
So now in optimized approach, we are doing binary search. Binary means either taking or not. Like binary means 0 or 1, true or false. So what we did in binary search, the logic is find the medium, middle element. Find the middle element and take 2 pointers. One is left or low or high. Means we're going define two, means taking 2 pointers. The left or any name you can take. Low will be first pointing to the starting element, and high will pointing to the end
Last
element.
element. Okay.
And now you will find the mean. Here the finding mean is like low plus high by 2. Initially I will change the code later. Okay, low plus high by 2. But there is a problem with the overflow problem. We solve that. So for this, the middle is, let's say, what is 0, 1, 2, 3, 4, 5. So 5 by 2, 2.5. So here, as we are taking integer, it will point to 2, right?
Okay. Okay.
Just so it will point to 2 as the meat is integer. So now check this 25 is greater than 17 or not, because I was I was trying to find 17, right? So it finds the 17 is left side, means smaller than meat. So it will not go to right side, it will go to left side. So it saves our time.
Okay.
As the array is sorted, right? So there is no other way, like 17 should maybe in the right side. So it is always in the smaller. 17 is always smaller to 25, right? And the
Right.
array is sorted. So that means that the element 17 is always be in the left side of this array, because the left side is smaller and right side is higher. So it is 25, the middle element. When it finds 17, 17 I am finding. So 17 is always smaller, so it goes to only left side. So now it becomes a smaller array, and you have to do again the same thing for the left array. So here what it did, high now change for the high now point to this element, mid minus 1.
Okay.
Now high is mid minus 1, and now you will again calculate the mid, and let's say mid is, you are understanding?
Yes. So can I go through the explanation myself? So let's say like we are using linear search, right? And let's say we're just trying to find 99. So it's going to search, go from the first, it's going to search first in the first index, again to the second, third, fourth, and fifth. It's going to find in the fifth index, right? So so that's for the linear search. But if we go through using binary search, it's going to half the array. That means like 1, 2, 3, 4, 5, 6. There are 6 items, so it's gonna go first to the 25 by itself, and it's gonna search in the right side, and again it's gonna half the array, and it's gonna search 99 like that way, right?
Yes. So in binary search, that logic is that is. So we are not searching the whole array. We are dividing the array, kind of divide and conquer. There is a concept in data structure.
And will that affect in time complexity or not?
Yes, it is log n only.
Oh, okay, gotcha.
So that is the reason that it is the time complexity is log n.
Gotcha.
Solve that. Sometimes in colleges they ask you to solve how you can do it in log n. So we'll check that. So here what we are doing the meet. We are finding the meet and checking the array is sorted and checking the elements I am trying to search is in left side or right side. And the based upon the decision we find. Yes. Now tell me again what you understand from this.
From binary search. Okay, so what I understand from binary search, like binary search will take 2 pointers. So one will be in the low side and one will be in the high side, right? Low will be the first element of the array and high will be the last element of the array. So it's gonna take another mid. So let's say like it's gonna divide the size of the array by 2, and it's going to go to the middle of the element. And if we are finding the higher number, so it's going to go to the higher side. And if you want to go to the lower element, you're going to go to the lower side. So again, it's going to let's say and let's say like it's going to the right side, right? So now the mid will be the new low, and it's going to again half the array, and we'll try to find the element then after.
Every time we are doing, yes. So here the 25, let's say medium. So high becomes now mid minus 1. Okay. Because we are searching only this side. 17. Let's say we are trying to find 70. So it is left side. So high change from here to here, because this is the now new array, because we discarded this, right? Discarded.
Okay.
Now this is the array that do the same for this also. So now let's say mid is here, and you are checking that mid is means the element in mid is greater or smaller. Based upon that decision, you have to go to right or left every time. So this problem is in lit code as well.
Okay.
Can we solve this problem?
Let's see. Give it a try.
So you must write a algorithm from login. Whenever you find something in login, your mind always click to it is binary search.
Oh, okay, gotcha.
Many questions you can find the constraints like you have to solve in login time. So whenever you find, remember, whenever you find something in login, your mind should always click that this is a binary search, and see the elements already are ascending orders. Array size is this size, and elements between these all integers are unique, and binary always do the same, like the elements should be unique. Do you know the logic? Because there may be two 17s, then it is difficult to search which 17s you are trying to search, right?
Can I try to search it? Can you give me the remote access for it? Like,
no, I think you cannot take the remote controller or to accept all requests.
due to like we're using the free version, maybe that's why.
I think you can now take the remote auto.
Let's see. I'm not seeing.
Control 2. Yes, you can, I think, take the remote.
How do I do it though? Do you know like how can I do this remote?
Hello.
Okay, I was just trying to search how can I take this remote.
You're already
It's
controlling my.
already okay. Got you. Okay, let's say int nums, right?
See the read the problem first.
Okay, given array of integer nums
It
which is
is
certain
first basic problem in array.
and an integer target, write a function to start target in nums. If target exists, then return its index. Otherwise, return -1. You must write now. Okay, let's say numbers down there 9. Output will be 4 because 9 is in index of
0,
4.
1, 2, 3, 4. Yes. So
And
first write the linear search. Log n. Sorry, in order of n. First write
okay,
the linear
okay,
search. Then you go to binary search.
okay.
Right?
Let's say okay, int length equals numbers dot length, right? I can do this, and we can say like, okay, we don't have to do target because target is already initialized. Uh, let's say for int I equals to 0, I less than length I plus, let's say uh, if nums at high
What equal target?
target, return we can do return 1,
Not
right?
one. No. It is trying to find the index. So what
Oh,
is the
okay,
index?
okay, let's do I,
Yes,
right?
good. Mm-hmm.
And we can, let's see if it finds I, right? We can just to break that statement.
Yes, you can do that.
So L, and if not, it's gonna go.
No, not doing the problem. This is
Oh, okay, or we can just throw. We don't have to do.
no. Yes, you can do after the for as well.
Or can I just do like return -1 directly, because like if it didn't find the element, you just can return -1, right?
Yes, it should return -1, but where you should return -1? Which line?
Okay, so give me a second, because because it's always returning -1, so it should be outside of uh no.
Outside of for loop.
Yep, yeah.
Otherwise, what will you do? It is fast return the -1. Okay, I am cutting. Means I cutting. I am cutting. No,
Okay,
not here. Here.
okay, return -1.
Right.
Okay.
Why? If you write in here, what will happen? See, first the element will not found here, so it will go to here, and it will return -1.
Right. Okay. Okay. Because every time it will. Oh, okay. So if
Now
it also.
when you return something, break will not reachable. Means when you return something,
Okay.
this statement means this from this line, it will goes to line number 2. So it will after this anything will not be reachable. Not break,
Okay.
not only break, anything will not be reachable after you return something, because that in my problem there I did not write like I did not return anything. So you should remember that when you return something, any other element, any other statements will not be compiled or executed.
Oh, okay, got the idea.
Compiled but not executed.
All right.
But time complexity is not good. Time complexity is only 8.6%. I did not
Why?
solve this question. Oh, this is linear search basically. You have to
Yeah.
do login. So now the problem. You understand this question?
Yes,
How?
I do. Uh-huh. I understand this one. Yep.
What is I here?
I means the index.
Num psi, right?
Yep.
Why 0 to less than length minus 1? Less than length? 0 less than length. Why this is not equal length?
Because if we do equal length, right, it's gonna it will need another one element, because it's gonna be extra element in there. Like let's say
0 to length means length minus 1, length plus 1. So it will go array index out of.
yeah.
0 to length. When you run the program, I think that will, okay, yes. When you run is a submit that, then it will, let's say, I'm doing length, means you are taking the length, then it will always throw the index out of.
Okay, got the idea. Because if we initialize as 0, there are two ways we can do that. One way we can do is like I less than length. Another way we can do is like I less than equals length minus 1. Right? Yep, there are two. Yep.
I equal.
Okay. Yep.
But index always start from 0, so we always do I from 0 and till length minus 1.
Okay.
And now do this in binary search.
Okay. If we want to do this in binary search,
this is also known as two-pointer approach. You are taking 2 pointers. It is also divide and conquer. Probably.
let's say int at low equals nums. No. Oh, okay. And the low and high will be the index, right? Not the element by itself.
No, it is always the index. Means low always be in 0 and high is always be the last.
Int high equals to numbers. Okay. Numbers. Can we do -1?
No.
No,
Numbers dot length.
Okay. Okay. Gotcha. Numbers dot length. Okay. Yeah, it's gonna return the numbers. And let's say if we want to do mid.
Here is the problem. How many elements are there? 0, 1, 2, 3, 4, 5.
Oh, it's gonna be -1.
5 elements. So now the 1, 2, 3, 4, 0, 1, 2, 3, 4. Oh, sorry. There is 5. And the elements are 6. So it is 5. That means the length minus 1.
-1. Okay. Got the idea.
I did not solve this problem. It is easy problem. That's it.
Okay, let's say low plus high divided by 2, right?
Yes, this way you can do the middle element. You can find the middle element, but there is a problem. The problem is that, let's say you have a big element like integer. We are taking integer, right? Integer has a limit. Let's say, what is the limit? 2 power 32. or 10 power 5, or sometimes we do prime numbers.
Right.
So let's say 2 power 32 in worst case. In worst case, let's say the high is let's say the array is of the maximum size of integer. Understand? That means it has 2 power 32 elements. Okay, and this is pointing to the last element, 2 power 32 minus 1, 2 power 32 minus 1. Let's say it is worst case. That means when you do low plus high, so that means when you are doing in worst case, say low plus high, low plus high, you are doing somehow in worst case, and that means sometimes it is overflow. In worst case, let's say high is 2 power 32 and say low is anything in 5 or 10. That is when you plus 5 with 2 power 32, that means it is beyond the range of integer.
Okay.
You are understanding?
Yes.
Because 2 power 32, let's say the high size means the in integer it is the max size.
Next.
So sometimes we do, okay, not taking the integer, but let's say in Java we do integer dot max. Sorry, integer dot just one thing. Just one thing. Hi, mat dot. I think the syntax is mat dot max value. No, sorry, integer dot max value. Yes. Yes. So that means integer dot. We do this in LeetCode as well. Max value. Integer dot max value means it is the max size of integer. Okay. Plus, let's say I am adding something, any element 10. Integer dot max value is the right side, means it, let's say it is high. In our case, let's say sometime, and it is low. 10 is low, so index is pointing to left point is 10th element, and right is pointing to this index. So now when you add the both, so that greater integer dot max value, right?
Yep.
Because that is 10x extra, so that beyond the range of max value. So it will throw a exception that it is out of bound exception.
Okay.
So we the good practice is low plus high, doing the same. It is also the same, high minus low. Now understand, both the lines are same. Okay, the first you do this low plus high, but because the interviewers always check this thing, which way you are doing the middle, and they will always ask you why you did this. It will be a out of bound exception, overflow, but I am doing the same using this. You understand?
Oh, okay. I got the point. Meaning, like, if we do low plus high, it's gonna be more than the number of elements integer gonna take, right? But
in
if we
most
do
cases, max value will be bound out of bound. But if we do high minus low, then plus low, see, both the lines are same,
right.
but I am doing a like cosmetic thing here, some changes, so that it do not go out of bound or overflow.
Okay, got the idea. Yep.
First, I am okay. So now, right?
Okay, let's say, and so we want the index, right? What we can do?
Middle. So what is the middle element here? 0, 1, 2, 3, 4, 5. 2.5, 0, 1, 2. Let's say 3 is middle. Now I am targeting is 9. So where should I go?
You should go on the right side.
Hmm. Hmm. And remember, middle we find every time. So every time middle will change. Every time middle will change. So better if we do means we calculate the middle inside a loop. And the logic should be while low greater than high. So always remember that high is always higher than low. So it will not cross each other. When it cross each other, then the loop will break.
Saurav, why did we put that mid inside the while loop? Because we are calculating the mid every time we are going to. Okay, got the idea. Okay.
Because every time you have to calculate the mid. Means every time the array will change, right? A smaller array will come, another smaller array will come.
Okay.
Let's say, see this is array. So
Right.
first, let's say I am dividing this array. I am going to right side. Okay. Again, I will divide this array. Again, I will divide this array. This way it will go, right?
Okay. Oh, okay. Got the idea. Okay.
Binary search. But binary search also is costly if the array element is not found. If let's say you are searching, but the element is not found in the array, you have to search till the end. So that is also costly in the worst case.
Okay.
Yes. Now, yes, you did the middle. And now in that case, you have to do some logic here. So first thing is low always lower than high. You find the middle, and next what you do?
So now the if let's say if the element is in the because 9 is right side, right? So what we can do is
High will modify, high will be updated, else low will be updated. So let's say it is low, it is high. When it finds the target is right side, when it finds the target is right side, low will be pointed to the last element of the first element. So in this new array, low will be the starting element.
okay.
And if we are going to right side, the high will be the end element, right? So high and low always change based upon your decision. Now, how can you change the high and low? There should be a constant.
So the high element will be the new mid. I mean, new high will be the mid, right? We just found.
No, actually, taking another example. See, taking this example only.
Okay.
Now, what is the mid? And searching is 9. Mid
middle
is
is 3.
3 means 0 1. Okay, I am taking this 3 means index I am doing that is 2, right? 0 1 2.
Yep.
Mid is now what is low and high?
For the first part, low is minus, 0, and the high is 12. And okay, so I got the idea. So for the second part, now the high will be the same, low will be 3, right?
Yes, it is 5. And now tell me. So let's say middle is 2, high is 0, and low is 0 and high is 5. Now target is 9. So I am checking the array index ERR of mid. ERR of mid. That means ERR of 2. What is ERR of 2? 3. Now 3 is greater than 9 or less than 9? 3 less than 9. So 3 is always less than 9. So that means low will be mid, and high will not change. High will always point to 12. If let's say if this is true, that becomes this. If this is true, that means let's say here the element is 44. That means 44 is greater than 9, because the array should be always sorted. It is a wrong example, but still, if this is true, then we should go to left side. So that means when you go to right side, always low should change. When you go to left side, high should change. You know, you understand this, because the array should always has 2 pointers. When you the new array, low is always there, but in new array high should change from last element to this element. Okay, that means high should mid -1.
Okay.
3. Solution I am not going. Try to understand. You have mid. You have to decide which part you should go, either left side or right side. If you are going to right side, that means your low should be updated. But high is always there in the right side, right? Low should be modified, because low was previously here, but now this array has gone. This side array is gone. So there should be a low, right? So the low should be here, this point. And let's say you are going to left side. You are going to left side. Low is here, but high was previously here. But the array is from the right side, array is gone. Then where should be the high? High should be
high plus 1. Mid plus 1. Sorry.
No, mid -1. Mid was previously here. So when you going to left, that means depend upon the condition. I will share some variants of binary search, some variants, but today we'll go to we will see the basic.
Okay. Nice.
So always low should not cross high till the time the loop will run. Mid we calculate and we'll check mid. Oh, sorry. Nums mid. Nums mid. You understand? Nums mid means the middle element. Finding the middle is greater than or target. I'm doing else for you. Okay. It will means I think you're struggling with this question. It is but very basic question. You have to practice this question. So we are checking these two conditions. Is that do we go to left side or right side? If we are going to right side, what we will do? That means, see, the mid element is smaller than target. Means target is in the right side. Target array is ascending order.
That means low with -1.
That means you have to go to right side. When you are going to right side, that means your low should be changed. So what should low? Low should be mid +1, and here high should be changed. High should point mid -1. There is a variation. I'm saying these sometimes we do -1, sometimes we do only mid. So there is a variation.
Okay. Got the idea.
And we are finding the target. So what should we return?
So we are finding the target. That's going to be return. The target return.
Take this example. Take this example and just write on the program.
Okay, let's say -1 is low, with a high, and it's going to go to 3.
First mid is 3. Okay.
Okay. It's
Now
going to
we
return
are going
mid. Hello.
See, we can do another just one. If mid, sorry, if nums dot mid equal target, then we return mid. It is basic condition. Okay. Else we are checking understand?
Yep. Okay. Okay, got the idea. I think I might have to go through it like a couple of times by myself too.
See, go to solution. I think they do not have written this. I think there is a slide, right? Yes, it's good. See, pivot. Pivot means here they are taking the middle.
Okay.
This mid. See, that is left, that is right. We are taking low or high name. Anything. You can left or right. Okay. So now pivot is pointing to 3. Okay. Go to next slide. So target is 9. That first the middle element was 3. When you find that 9 is greater than pivot or middle, means middle element 3, middle is 3 and 9 is greater, so we go to the right side. When you go to right side, that left should be modified. Right is always there in the new array, right is inside the new array, so left should be modified to mid +1. If let's say the element is in the right side, target element, then you have to go to right side, left side, sorry. If it is lower, then you should go to left side, and then that high should be modified.
Okay.
I think you do not understand it well, right?
I mean, I got the idea, but I might have to go through it one more time by myself first.
Take a pen and paper for this.
Okay. So let me go to the reports. So it has 3 variations for it, right?
Yes, it has 3. Where is 3 variations? Is there anyone written? Variations are 3, yes. Where it is written?
Yeah. They might have binary search.
Variations are depend upon the the declaration of the middle and all. That is just you have to change the pointers. Sometimes -1, sometimes +1, but the logic is same. But I cannot see the variations. See variations written here. You have the premium.
No, I don't. Is premium good? Should I take that for practice or?
No. Premium do not need actually. There is lead code free website as well. Oh, I will share. But first understand this. First understand this.
Okay.
Take a pen and paper.
Okay.
I think
So
we should clear this concept. Next day we'll move to many other questions. They are more complicated. Means using the binary search. See, there is a tag already, binary search. There is lots of problem using binary search. Binary search. So there, all these problems are using binary search only.
okay.
Concept is the binary search. So now go to give me an example of binary search. Tell me.
Binary search. Okay. So let's say we have an array of 5, right?
You can
There are 5.
do you have a screen touch like anything tab? Give an example.
I can draw. I can say the, but I can draw it. Okay. So let's say you got 5 elements on it. Let's say you have 1, 2, 3. Let's say you got like 10, 11, 12, 13. You can do 1, 2, 3, 4, 5 as well. So now there are 5 elements on it, right? And the low will be the element at index. No.
0.
It's going to be 0, right? High will be the.
It is initially. It is initial. High should be the last element. Now
I should be in the index of last element, right? Right. So,
it is. These are index. These are index. Always index. Yes. Pointers.
Okay. These are all the index. So now what we can do is run a while loop and find the mid element, so that like every time the while loop runs. So let's say the element is in the right. So now
we are finding. Let's say we are trying to find 11. Yes, 11. We are trying to.
Yes. Let's say 11. Now for this, low will be changed. Oh no, yeah, low will be changed.
Why low will change?
Mid -1 because it's the element is on the right side.
The element is the right side, so that means mid 3. We are checking what 3 greater than 11 or 3 less than 11. So if 3 less than 11, that means we should go to right side.
Right. Correct.
So now the new array becomes this.
Right. True.
And we discarded this.
Okay.
When you discard this, low gone. So the new low becomes here. So what is the new low? Mid. That was mid +1. That means mid +1. So that is mid +1. This 4 is mid +1, and high is this one. So remember low. Forget about low. This is 4 becomes mid plus 1, right?
Yep.
So that means low. We are updating low to mid plus 1. And now this part of the array gone.
Okay, Saurabh, I got one question for you. So if we are going to the right side, so should we always do mid plus 1?
No, sometimes we do mid.
Okay.
Depend upon the variations. But for you, the basic understanding, just remember mid plus 1. Sometimes variation is there. Depend upon the sometimes. I will show you. I will come to the problems. But remember this. This is basic.
Okay.
So mid plus 1.
Okay.
Always is. Not always, but for this, remember. So mid plus 1, that becomes new array. And let's say we are going to left side. That means that will be mid minus 1, right? Mid minus 1.
Right.
But low will not change because low is previously there. High should change. Here mid minus 1 means high. Just it is an intuition. Just think about that. When you go to left side, that high should be modified, right? Because the right side is gone. So where should be high? High should be the last element of the array. So in the new array, the right side, the rightmost side would be the high pointer. That means the previous mid minus 1. And see what we did here. The same thing. You can do some test cases here. You can modify the test cases. But let's say sometimes array should not be shorted. That time you should do a, here it is they told that it is in ascending order. So sometimes it do not that array should not be shorted. That in that time you should do a arrays dot sort.
Okay, got the idea.
And no. Okay. I should not go the variation today.
Okay, so so are we meeting the same time for tomorrow?
Tomorrow, yes. A few days I have less work in office, so we can do regular
time.
I think yes, next week I have the new project will start again. Okay, go do one thing. First, go today, read this binary search.
Okay.
Go through the binary search very carefully and try some binary search problems. Let's say some beautiful questions are there. Do some binary search is not coming. Search insertion point. Yes, it is easy problem. Binary search we did.
Yep.
Insertion of two arrays. Insertion of two arrays. It missing. It is okay. Search insertion position. Read the problem. Given a sorted array and listing integer and a target value, return the index or target found. If not found, the index where it would be return the index where it would be it were inserted in order. See, that is login. Login means you should always click that this is binary search. Not always, but the understanding the problem, you can understand the means after reading the problem. You can, if you understand this is a searching problem, that and login is given, then you should go with binary search.
Okay, got the idea.
Okay, try to solve this problem after it is similar kind of problem, the last one. Okay,
Okay. No.
first go to binary search once twice, solve this problem in lit code by yourself without watching the any tutorial.
Okay, gotcha.
Just go pen and paper and solve this and come to this problem. It is
35. Okay, got the idea. And so for the payment, like you do have PayPal, right?
PayPal, yes. But actually
So
PayPal takes some charges extra. One website is good. Some students send me in Wise. Wise. You can use Wise as well.
how much does it charge, like, to send the money?
It charges for you.
I think so. It's gonna charge it from me, right?
I do not know actually, because it does not charge me actually, but PayPal charges me.
So you mean like the receiver don't get charged? You mean?
Yes, I think yes. In Wise, receiver do not get, means they do not take charge from receiver, but PayPal takes charges from receiver.
Let me see. Okay, Wise takes the fees. Oh, let's say if you're sending USD to rupees, yeah,